A covered basket of flower has some lilies and roses. In search of the rose, Sweetie and Shweta alternately pick up a flower from the basket and puts it back if it is not a rose. Sweetie is 3 times more likely to be the first one to pick a rose. If Sweetie begins this rose hunt, there are 60 lilies. Find the number of roses. So let's call Sweetie A, let's call Shweta B. So first let us find out the probability of A winning and then probability of B winning, and they have given the relation between the two. Probability of A winning is 3 times the probability of B, and from that, if we assume the roses to be x, from that we will get an equation for x and we will have to solve that. So first probability of A winning will be, it is given that Sweetie, that is A, begins this rose hunt. So she is the first one to go. So either she can win in the first go. So in the first go she is getting the roses, or she did not get the rose in the first go. But then we are finding the probability of A winning. So even B will not get the rose since she is going second. And in the third trial, A can get the rose. This is one of the cases. Then another case is she doesn't get in the first go, B doesn't get in the second go, she doesn't get in the third go either, B doesn't get in the fourth go, but A gets it in fifth go. So this will just go on, right? And at every alternating position, that is at 1, 3, 5, every alternating position there is a chance for A to win. So to write this, it is basically x upon the total number of flowers is x and 60 lilies, so x plus 60. This will be the probability of getting a rose, x upon x plus 60. And next is not a rose, not a rose, a rose. So for that we will have to write the probability of getting a lily. So there are 60 lilies upon the total number of flowers, so that's x plus 60. And this happens twice, not a rose, not a rose, so square. And then she's getting a rose, so it is x upon x plus 60. And this will just go on, and you will observe that it is an infinite GP. The first term is this and the common ratio is this. Now coming to the probability of B winning. Now if B wins, probability of B winning. So A goes first, but A did not get the rose. And B went second and B got the rose. This is the first case. Then A goes, did not get, B goes, did not get, A goes again, did not get. Then B gets the rose. So this is the second case. So again it's a pattern and it will go on infinitely. So let's write the equation for this. We know that R dash is the probability of getting a lily, so that is 60 upon x plus 60, and into R, probability of getting a rose, that is x upon x plus 60, plus 3 times not a lily, so 60 upon 3 times not a rose, so 60 upon x plus 60 cube, and 1 time a rose, x upon x plus 60. So again it's an infinite GP with the first term as this and the common ratio as 60 upon x plus 60 square, the whole square. Okay, so now if you compare these two equations, probability of A winning and probability of B winning, you will see that they are exactly the same, except that in the second case of probability of B winning, we are just multiplying the whole first equation by R dash. So we can write probability of B winning is equal to R dash probability of A winning. That is correct, isn't it? Because there's R over here, there's R dash R dash R, R dash R dash R, and it will just go on. So it is like this, and we know the value of r dash, it is 60 upon x plus 60 into PA. Okay, so this is the equation we have. Now at this point we will use the extra information that they gave, that probability of A winning is 3 times more than the probability of B winning. So in that case, probability of B upon probability of A is equal to 1 upon 3 is equal to 60 upon x plus 60. So let's calculate this. This will be 180 is equal to x plus 60. So x is equal to 120. 120, and we have to find x only, right? So 120 is our answer.